how can we get a sample of air to go to the dew point? If this happens, again, we'll have vapor starting to condense into water or deposit into ice, depending on our temperature. If the dew point's below freezing, below 0 Celsius, then obviously we're going to get the ice. Above, we'll get the water. Again, temperature will stay at that as long as we are going through the condensing process. It's not until we get a significant amount of water removed from the air, and thus a lower dew point, because there's less water in the air, that the temperature could drop further. How does humidity affect us? Again, at different temperatures, the maximum amount of water vapor that will exist changes. So, cold air, there will be less evaporation when it's cold, so the maximum amount of water with cold air is less than with warm air. Again, it's the water, it's not the air that's causing this. You notice this, come winter time, outside temperature is cold, so you turn on the heat, warm the air, but unless you also have a humidifier, that air is getting warmer, we're not adding water, the relative humidity goes down, and that air feels dry. If we have relatively low humidity, we have lots of evaporation. If we could move this clothesline to here, the clothes would be dry quite quickly. Humidity, we also notice it. It affects how things feel, how comfortable the air around us feels to us. Moving air helps promote evaporation. As the wind blows, the water that evaporates gets moved away. And so if it's not there anymore, it's not condensing right back in the same place. It gives more chance for water to evaporate instead of condensing back and releasing that latent heat once more. So evaporating, we're putting latent heat in, and if that now warmer water vapor is carried away by the wind, it doesn't just condense right back where it was and release that heat once more. And this leads to the effect with sweating. When we notice sweating, it tends to be making us soggy and smelly, and being soggy and smelly is not particularly useful. Well, why would you sweat? Well, we notice it when it's not working. And when sweating is working, it's evaporating and not causing the problems. But for water to evaporate, it has to get warmer. We have to put that latent heat into it, and so transforming that from liquid water to water vapor. Okay, where's latent heat coming from? If it's sweat, it's coming from you. So the sweat is taking heat from you and carrying it off as water vapor. So say if there's a breeze, the warmth that came from you is going into water vapor and blowing on away, and you're cooled off. But if there's high humidity, not much of a breeze, then just as much is, I would say it's close to saturation. You've got just about as much water that's condensing as evaporating, and so the net heat absorbed by water to evaporate is just about balanced by the amount that's being released as water condenses, and it's not moving away from you, and you're not getting cooled off. Kind of like the joke about the guy who was going to take a hike through the desert, and so in order to keep cool, he was going to carry a car door and roll down the window when he got hot. No, that would not help. Rolling down the car window while your car is going helps because that gets air moving. And so that moving air helps carry the evaporated sweat away from you and cool you off. If the air is not moving, you don't get that effect and it doesn't feel cooler. High humidity, we're getting condensation, catching up with evaporation, the heat being released versus absorbed. We're not cooling things off. Measure of this is the heat index, how hot it feels due to the humidity. Here's a diagram of that. And we see the pattern. If it's less than 80 degrees out, well, yeah, we don't need to cool off particularly, so not much effect there. As it gets more humid, the effect is bigger. As it gets hotter, it's bigger. And also, at a higher temperature, the same amount of humidity has a bigger impact. So for example, if it's 80 degrees Fahrenheit out there, and 40% humidity, it just feels like 80 degrees. But if it's 100 degrees out there, and it's 40% humidity, it feels like 109. Much more significant effect there. So the hotter it already is, the less extra humidity it takes to make it feel much worse. And if it's very humid, a more modest temperature, say in the upper 80s, can feel like a dangerously hot temperature over 100. So definitely humid days. In the summer, you need to be extra careful about not overheating. But there are times when we don't want to cool off. When it's already cold, there's still wind, there's still humidity, and these affect things. Water, even as vapor, has a somewhat higher heat capacity than dry air. So more humid air does absorb heat a little better. Not a big effect, but it does happen. Also, if you're standing there and it's cold, the air next to you is starting to get warmed up from you. If that air just sits there next to you, then before too long you've got a little layer of warm air next to you. Doesn't feel so bad. But if the wind is blowing, that air next to you doesn't get warmed up before it's moved on, and here comes new cold air to take its place. So moving air makes you feel colder than still air when it's cold. And the way that it feels colder is the wind chill factor. The real temperature isn't changed by the wind, but it feels colder. And you cool off quicker, which leads to potentially problems with extra cold, like frostbite. Here's a chart for that. As we saw with the heat, if the temperature is already bad, it takes less wind to make it feel a lot worse. So say 40 degrees Fahrenheit, about 5 degrees Celsius, and the breeze is blowing at 5 miles an hour, the equivalent of driving with your windows rolled down at 5 miles an hour. Well then, instead of 40, it feels like 36. Yeah, that's colder, but not too bad. If it's all the way down at 0 Fahrenheit, then that, instead of making it feel 4 degrees Fahrenheit colder, makes it feel 11 degrees colder. Noticeable difference there. And of course, faster wind does make you feel colder. Well, once you get to 60-mile-an-hour wind, it feels awful anyway. And any faster than that doesn't make much difference. But if you're already cold, it takes much less wind to make it feel a lot worse than if it's not so cold. The shading shows how quickly you get frostbite under those temperature conditions.